Okay, so last time we left off with looking at lithium and what its electron configuration was. So you just had a little bit of background of where we were going here. We talked about how we always fill the top energy or the lowest energy level first. So an analogy for this would be if you're going up the steps, would you try to step on the first step or would you try to jump to the fifth step first, right? You always start with the first step. So this is going to be our first step, first energy level. Remember, this is the S section. Helium, we move over here. This is our P section. This is our D section here in the middle, and then our F section is down below. So our first rule here, the off-ball principle, tells us that the electrons are going to fill their sublevels, so the total energy is the minimum. So the lowest available subshell first, and then we move higher. So we have to fill S1 and then S2. Then we have to go down here to 2. We fill 2S1, 2S2. Then we move across to 2P1, 2P2, 3, 4, 5, 6. Then we would move to 3S2, then 4S1, 2, 3, 4, 5, 6, and then we're down to 4S. This is where it starts getting just a little bit tricky, because if you remember, we wrote on here the other day that this is our 3D. Okay, so when you get past 4S2, after calcium fills, okay, its energy level, we then move to 3D. Okay, and the reason that this happens is just because these D orbitals act a little bit differently than the other valence shell orbitals, which are S and P. So then we would fill 3D 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we're over here, but we're still in 4, so this would be our 4P. 1, 2, 3, 4, 5, and 6. Then we come down to 5 and we continue that pattern. Okay. So again, rules we have to remember, we always start at this lowest energy level at the top. We fill S and then we go down here because 1 only has an S, 2 has S and P, so we would fill those up, then 3. So let's say we want to stop at nitrogen. Okay. We would fill with our 1S2. And if we want to draw boxes, we can. You don't always have to draw boxes. Okay, only when that's asked. And then we would move down to our second energy level here, and we would fill our 2s2, because we have to have our 2s full before we can move to our 2p. Okay, so now we move over here to our 2p, and we would have it 2p1, 2p2, and 2p3. And that's where we would stop because we don't have any of these electrons. So we would write our 2p3, and again, remember, there are 3 orbitals in our p, so you would have to draw 3 boxes, and we would represent an electron in each, because this would be our second rule here. So we can scroll down, placing electrons in unoccupied orbitals before you occupy them. So it's kind of like when you guys go on to the bus, you pick an empty seat before you sit with somebody typically. Okay, so that's what this is saying. Place electrons in an unoccupied orbital of the same energy level before you double them up. So that's why I put 1 electron in each box. Now, if I was on oxygen, then I would go back and I would double up right here. Okay, but this one's nitrogen, so that's not going to happen. So let's try another one here. I know I just moved everything and kind of made it goofy here, but I wanted you to be able to read that rule. Okay, so let's say we're going to do neon this time. Okay, we're going to do neon. Let me get back on my pen here. Okay, so neon has 10 electrons total. So again, we're having to start our lowest energy level, so you'll soon find out all electron configurations start with 1s2, except for hydrogen, which is 1s1. We move down here to 2s2. And then across to 2p. And now this time we're on neon, so it's going to be 2p. 1, 2, 3, 4, 5, 6. So this time we would end with 2p6. Now if we draw our boxes in, our S is going to be full, 1 up, 1 down, 2s2, 1 up, 1 down, and then 2p again, 3 orbitals, so we have to draw 3 boxes, and my boxes are horrible here. We would put 1 electron in each, empty bus seats, remember, and then come back, and then we would double up until we used all 6 of our electrons. So this one is equal to neon, and this one is equal to nitrogen. Okay. The last rule It's just that if you have 2 electrons in an orbital, like I just showed, either an s orbital or if we have a p orbital with 3 boxes here, they have to have opposite spins. So we indicate that with 1 up arrow and 1 down arrow. So that's the reason why I've been drawing the arrows the way I have. Okay. So again, these configurations just give us an idea of where these electrons are actually located within our atom. So we've got this positive nucleus. We're going to have an s orbital where these electrons can be going all over the place. Then we have a 2s orbital. Then we have a 2p orbital on top of that. Each of these can hold 2 where the electrons are going all over the place. Then we would go to a 3s orbital, which is circular shaped, and then a 3p orbital, and then continue that on. And these are just areas where those electrons can be moving around. Okay. So let's say we have to determine how many electrons we actually have. Okay, remember that charge is equal to protons minus electrons. If we have something with a charge like this, okay, we have to look at bromine. Its atomic number is 35. So there should be 35 protons in here. If we have a negative number, that means we have more electrons. If our charge is negative 1, that's going to be equal to our protons minus our electrons. So if we're trying to figure out how many electrons we have, we would have to subtract 35 over. And that tells us we have 36 electrons. So we have 1 more electron than protons, and remember protons are positive. So positive protons, negative electrons. If we have a negative charge, we have extra electrons. Okay? And this shows the work. So when we're writing our electron configurations, let's say we're doing chlorine, we'll do this one real quick. It's number 17. When we get done with our configuration, we have to have 17 electrons. Okay, so let's go back up to our periodic table. And again, we start with our 1s2 right here. Then we come down to our 2s2. We go across the periodic table, read it just like a book. We go from number 4 to number 5 over here, which is boron, and then we go all the way through here. We fill that up to neon, which is going to give us a 2p6. So now we're ready to go to the 3rd energy level, 3s2. That one has to be full before we can move on. And then we're going to move over to the 3p section. Again, we go from number 12 here to number 13 here, and then we would go 1, 2, 3, 4, 5. So we're going to end our configuration on 3p5. If we add all of these numbers of electrons up, that should be equal to 17.